Look at your fingertip right now. Those tiny ridges are not there to help you grip things. That turns out to be a myth. Fingerprints are one of the most famous features of the human body. Every crime drama treats them as personal signatures. Every textbook will tell you they evolved to improve our grip. But when scientists actually tested that idea in the lab, the grip theory fell apart. Fingerprints do not give you more friction. In some experiments, they give you slightly less. So why are they there at all? It turns out, fingerprints have almost nothing to do with holding objects and everything to do with how you feel them. They are a signal amplifier wired directly into your nervous system. Here's how it works. For over 100 years, the official answer was that fingerprints improved grip, the same way tire treads grip wet pavement. Then in 2009, researchers at the University of Manchester put it to the test. They pressed fingertips against smooth acrylic surfaces under controlled force and measured the actual friction. The result was the opposite of what everyone expected. Fingerprints reduced the contact area between the skin and the surface by about 33%. Less contact means less friction, not more. On a smooth, hard surface, your fingerprints actually make you a slightly worse gripper than if your fingers were completely smooth. The classic explanation had been wrong for a century. The ridges were clearly there for something, but it was not traction. The real answer came from a different field entirely. Deep inside the skin of your fingertip are sensors called Pacinian corpuscles. They are microscopic pressure receivers that respond best to vibrations at around 250 hertz, which is exactly the frequency your skin vibrates at when you slide a fingertip across a textured surface. When researchers modeled what happens as your finger moves, they found that fingerprints act like a tuning fork. The ridges catch on the tiny bumps of the surface and amplify the resulting vibrations by a factor of about 100, feeding a much stronger signal into the Pacinian corpuscles. Without fingerprints, that vibration would be weak and noisy. With them, it is a clean, high-fidelity signal that tells your brain the exact texture of what you are touching. Your fingerprints are not gripping the world. They are listening to it. Fingerprints form before you are born, between weeks 13 and 19 of fetal development. They are the product of three physical forces fighting each other. The top layer of fetal skin grows at one rate, the layer underneath grows at a different rate, and the connective tissue in between pulls sideways as the finger itself is lengthening. When these three forces collide, the skin buckles in patterns that are mathematically unstable. Tiny differences in fluid pressure, finger position, or the density of cells in a single spot steer those buckles in completely different directions. The result is that even identical twins, who share 100% of their DNA, have different fingerprints. Your prints are not coded in your genes. They are a frozen record of the specific chaos happening in your mother's womb on a few specific days of your development. That developmental chaos is why no two fingerprints on Earth are alike. The odds of two people sharing a print are estimated at about 1 in 64 billion, which is far more than the total number of humans who have ever lived. Koalas are one of the only other animals that have fingerprints so similar to ours that forensic experts have been fooled by them at crime scenes. But for humans, the ridges are doing double duty. They make you identifiable as an individual, and they turn your fingertips into the most sensitive tactile instruments in the animal kingdom. You can feel a single bump only 10 nanometers tall, about 10,000 times smaller than a human hair. That is less about grabbing a rock and more about reading a world of texture your ancestors needed to survive, one vibration at a time. If this changed how you see your own hands, subscribe to Curious Science for more. There is a stranger story behind almost every part of your body than you think.